Good day, grade 5s. This is your math teacher, Mr. McMurdo here again, and this is the second video in our unit review for Unit 1 on number theory. Now, in class, I showed you that there are divisibility rules that can help you determine whether or not a number is divisible by another number. So if somebody came running up to you on the side of the street and asked you if 76,932 was divisible by 2, you would be able to say, yes, actually, it is divisible by 2. And then the other person would say, thank you, sir, or madame, you've saved my life. So you could, theoretically, save somebody's life in a matter of 2 to 3 seconds by answering a question whether or not a number is divisible by another number. So in this review video, I'm just going to quickly go through the divisibility rules which we covered in class. The first divisibility rule that we covered was determining whether or not a number was divisible by 2. Now, a number is divisible by 2 when the number ends in an even number, which in turn means that the number must end in 0, 2, 4, 6, or 8. If the number ends in any of these even numbers, you know that the number is divisible by 2. The second rule which we covered was trying to determine whether or not a number is divisible by 3. A number is divisible by 3 when the digits of the number add to a number which is divisible by 3. The sum of the digits must be divisible by 3 for that number to be divisible by 3. Now, a number is divisible by 6 when the number is divisible by 2 and 3, which means the number must end in an even number and the sum of its digits must be divisible by 3. The fourth divisibility rule which we covered was a number is divisible by 9 when the sum of its digits are divisible by 9. Fifth rule, this is the fifth rule of 6. The fifth rule is a number is divisible by 5 excuse me, when the number ends in a 5 or 0. And finally, our last rule, how can we determine whether or not a number is divisible by 10? Well, a number is divisible by 10 when the number ends in 0. So just to review, our divisibility rules are: a number is divisible by 2 when the number ends in an even number, 0, 2, 4, 6, or 8. A number is divisible by 3 when the digits of the number add to a number which is divisible by 3. Or another way of putting that is the sum of its digits is divisible by 3. A number is divisible by 6 when the number is divisible by 2 and 3, which means the number must end in an even number, and the sum of its digits must be divisible by 3. A number is divisible by 9 when the sum of its digits are divisible by 9. A number is divisible by 5 when the number ends in 5 or 0. A number is divisible by 10 when the number ends in 0. Now we can use these tests to determine the following. If I gave you these 3 numbers, you would be able to check whether or not these numbers were divisible by 2, 3, 5, 6, or 9. Looking at the first number here, 975,324. Well, first thing we want to do is check to see if it's divisible by 2. Well, this number ends in an even number, so yes, it is divisible by 2. Now, we want to check to see whether or not it is divisible by 3. Well, we need to add up the digits. 9 plus 7 is 16. 16 plus 5 is 21. Plus 3 is 24. Plus 2 is 26. And plus 4 is 30. Well, 30 is divisible by 3. So yes, that number is divisible by 3. Now, we know that this number is divisible by 2 and 3, which means that it is divisible by 6. Now, looking at the last digit in this number, does it end in 0? No, it doesn't end in 0, so it's not divisible by 10. Does it end in 5? No, so we know it's not divisible by 5. Now let's add up the digits again. So once again, the sum of the digits is 30. Is 30 divisible by 9? No, so it's not. So this number is not divisible by 5, 9, or 10. Moving on, let's look at the next number, 33,726. Well, we know that the last digit is even, so it is divisible by 2. Now, let's add up the digits. 3 plus 3 is 6, plus 7 is 13, plus 2 is 15, plus 6 is 21. So we know that this number is divisible by 3. Does the number end in 5? No, it does not. So we know it's not divisible by 5. Sorry, it is divisible by 2 and it is divisible by 3, which means that it is divisible by 6. Let's add up the digits again. 3 plus 3 is 6, plus 7 is 13, plus 2 is 15, plus 6 is 21. Is 21 divisible by 9? No, it is not. So that number is not divisible by 9. Does it end in 0? It does not end in 0, which means it is not divisible by 10. Therefore, 33,726 is divisible by 2, 3, and 6. Moving on to the next number. Well, let's look at the last digit of the number. The last digit of this number is 5. Is 5 even? No, 5 is not even, so it does not end. So it is not divisible by 2. Now, if we add up the digits, 7 plus 5 plus 2 plus 5 is equal to 19. Well, 19 is not divisible by 3, so we know that 7,525 is not divisible by 3. Now, moving on to 5. We know a number is divisible by 5 if it ends in 5. Well, 7,525 does end in a 5. So we know that it is divisible by 5. Moving on to the next number, 9. Well, once again, if you add up the digits of a number and that sum is divisible by 9, then you know it's divisible by 9. Well, 7 plus 5 is 12, plus 2 is 14, plus 5 is 19. Well, 19 is not divisible by 9, which means that 7,525 is not divisible by 9. And then we know if a number is divisible by 10 if it ends in 0. Well, once again, this number does not end in 0. So we know by using our divisibility rules that 7,525 25 is only divisible by 5. That takes us to the end of this review video for our divisibility rules. Once again, your notes for this topic are posted in Google Classroom. You can use this video to review the concept and do practice questions, and then check with the calculator to determine whether or not you're following the rules correctly. I hope you have a wonderful day, and thank you for listening and watching.